Okay, the quiz. It's now too late. The quiz was a little bit more challenging, I admit. You're given the graph and you have to come up with information about stuff in order to get it. Okay, now whenever you get a graph like this, you could either make it a sine or a cosine. Some of you were wondering, do I have to do both? For this particular question, you could have done either sine or cosine since they have the same general shape, but it just asks for a particular one, so sine function. Okay, first thing I noticed is that for a sine function, it would normally go 0 up, 0 down, 0. This one starts down, so that tells me there's going to be a negative. Okay. All right, I find the amplitude. You can use a formula, maximum minus minimum divided by 2. So the maximum is 3, the minimum is -1. 3 minus a -1 divided by 2 is 2. So the amplitude is 2, so there's going to be 2 in front. Okay, and so yeah, since the graph starts down, then A is -2 is what I was indicating here. Okay, so there's a negative there. Okay, the period, how far is it from here to here? Well, 5 pi over 6 minus pi over 6, that's one period. That's 4 pi over 6 or 2 pi over 3. I set it equal to the formula of 2 pi over b, and that gives me a b of 3. So that means there should be a coefficient of 3 in front of the whole thing. Okay, then I take the regular sine function, which starts at the origin, but this is pi over 6 to the right, and then 1 up. So -2 sine 3 parentheses x minus pi over 6 plus 1. Okay, now some of you had it where this was distributed in, like 3x minus pi over 2. Okay, it is the same thing. I personally don't prefer that. Okay, so this is sort of the way that I want it done. But if you gave it to the other way, I went ahead and took it. And besides, that's the way the book does it also. Okay, but to me, this is easier. Okay, negative because it starts down. Amplitude is 2. Okay, maximum minus minimum divided by 2. Also, if you look at the midline, so to speak, it used to start at 0, but now this starts at 1, and they even give me this little midline here, so that means you know it's going to be a plus 1. Okay, the period was 5 pi over 6 minus pi over 6. That comes out to be 2 pi over 3. By formula, that's 2 pi over b, so that tells me b is 3. And this used to be the origin, so that moves pi over 6 over and 1 up. So pi over 6 to the right and then 1 up. Okay. Okay, second one, it's a cosine function. This is -1, -2.5, -0.5, -3.5, 0, comma, -2.5. So there's a lot of negatives. Okay, if this is cosine type, cosine starts at the maximum. This is the maximum, so that's fine. So maximum 0, quote unquote, minimum 0, maximum. So I don't need to put any negative on it. Okay, amplitude. It's maximum minus minimum divided by 2. So the highest is -2.5. Subtract a -3.5, divide that by 2, it's a half. So the amplitude's a half. The period is 1. How far is it from -1 to 0? 1 unit. So by formula, that's 2 pi over b. Okay, so that means b is equal to 2 pi. So my coefficient is 2 pi. Okay, yeah, you can tell by this midline here that it's 3 units down, so it's going to be a -3. Okay, it's not -2.5, because remember the cosine doesn't start at 0, 0. It normally starts at 0, 1. But in this case, because the amplitude is only a half, it would normally start at 0, comma, a half. Okay, and it shifted down 3. And yes, because they give it to me over here, 1 unit to the left, you should put cosine 2 pi parentheses x plus pi over 1. Some of you were noticing that if you didn't have it, you'd end up with the same graph, which is true. Okay, that's actually true, but you were supposed to base it off of the graph. So off the graph, you shifted 1 to the left. And again, some of you put 2 pi x plus 2 pi. You notice that's more writing. You had to write 2 pi twice. Okay, so I took it, but that was, you know, and that's the way the book has it. That's not my preference, and that doesn't sort of show me the translation idea of moving left or right and then up or down. Okay, so this is the answer key to the quiz. It's being recorded, so you want to look at that later. And I know some of you said I didn't get to it yet. Yeah, I know. So if you submitted yesterday, Sunday, anytime, I may not have gotten to it yet. You know, I have a 24-hour turnaround. So normally for quizzes, if you give it to me Friday or Saturday, I can usually give it back to you by the next day and maybe you have a chance to redo it, but not on Sunday or Monday. At least I'm not promising it. Actually, I'm not making the promise to any of you. So if I happen to grade your quiz early and I make comments, that's just icing on the cake. That's gravy. I'm not required to do that. I mean, just think of what normally happens when you take a quiz, right? Normally, if we were meeting face to face, if we took a quiz, you would submit it on Friday. That's it. You don't get to see it back until Monday, right? So there's no second chance. So the fact that I'm giving you a second chance doesn't mean you should insist on it. Okay, so it's just icing on the cake. If I happen to do that, fine. But I never promised that I was going to do that for anybody. Okay, so if I do get to it, then that's just extra. Okay, so that's that. All right, so we were here. We got plenty of time. I just have 4.6 to do. I think I can finish 4.6 today. So once again, we're probably going to finish early again today. We only have 2 sections left, 4.7 and 4.8. So the next exam is on November the 6th, it looks like. Okay, we have a lot of spare days, buffer days. They're not holidays necessarily, unless I get sick or my internet goes down, that stuff again. But if I finish 4.6, then we only have 2 sections left for all of this week and all of next week. Okay, so again, this Friday, we're likely to have another quiz, and then after that, exam 4. Okay, so this is the exam that covers the most amount of material. It's a review of Trig. Now start building up your cheat sheet now, your formula sheet. And after that, in my opinion, the semester goes fast. Every time in the fall, once we hit November, things kind of go fast. We get holidays. We got Veterans Day and Thanksgiving. Then, of course, once December comes around, everybody's thinking about the holidays and all that stuff, and we're done pretty fast after that, right? And if I'm not mistaken, I think we only have about 7 weeks left. 1, 2, 3, 4, 5, 6, 7. Yeah, so we only have 7 weeks, and they're not even all full weeks. We have we have a Veterans Day week. That's only 4 days. We have Thanksgiving. That's only 3 days. And then the last week, well, we just kind of get ready for the final exam, so to speak. I'll talk more about the final exam when it comes to it. And then we're done. Okay. All right, so you should work on this homework. This is what's due. And then please notice chapter 5 is very short. And chapter 6 is still kind of short in comparison to our super long chapter 4, right? Yeah, I mean, it's not going to be all completely easy. We finish all this because of all the holidays, right? We got, the Veterans Day coming up and Thanksgiving and all that stuff. But we'll see how it goes. Okay, so let me go on to 4.6. I will likely finish early. So same thing, when I finish my formal lecture, I'll stop, let you ask questions. And if there are no questions, we're done. And that may very well be the pattern for the rest of the week, assuming, I don't cancel class, I got sick, or my internet is down, and all that stuff. Okay. All right, so let's get back to where we were. Okay, so we have some graphs here. I'll show you these graphs. And then we have some equations to solve. And then that's pretty much about it, right? All right, so here we go. So last time I showed you 17, I will hit the highlights of it again. And yes, it almost looks like I'm going to pretty much end up doing almost all the homework problems, but I'm sure you don't mind that much. Okay, y equals 3 tangent x. So you take the basic tangent function, which looks like this. Okay, and if you want to put this in your cheat sheet, you may. Okay, so go to the origin. One period is from negative pi over 2 to pi over 2. So you can kind of get by with just this, just that piece right there, knowing that these are just copy and paste. Okay, so asymptote always goes up. Okay, 1/4 of the way, you're down at -1. 3/4 of the way, you're at +1. So if I put a 3 in front, okay, the red was the original tangent. You multiply all the y values by 3. So what happens at the origin? 0 times 3 is still 0, so it still goes through the origin. But over here at pi over 4, the y value is 1. But if you multiply it by 3, now it's up at 3. So this shoots up higher. Okay, but over here, this is what? Negative pi over 4, -1. Well, -1 times 3 is -3, so it goes down 3 times as far. Okay, so in green, the green one is 3 tan x. Okay, still goes through the origin, shoots up higher on this side, shoots lower on this side, but you still have the same asymptotes. Okay, so the asymptotes stay the same. Okay. Here is 19, please. -2 secant x. Okay, so I start with a basic secant function, which I gave you earlier. So where was my secant function? Right here, right? So in green was the secant, one period, branch like that, and that, and that. Again, both cosecant and secant have a lot of U-shape, upside down U-shape, U-shape, upside down U-shape. And even though I only showed you this again for secant, it's the same shape. If you keep going, there's a U there, upside down U, U, and so on. Same thing here. If you keep the U going, it goes like that. The next one goes like so. Okay, so what I have in green is the original secant. Okay, and now multiplied by -2. Oh, I'm sorry. The red is the original secant. Red is secant. Okay, so here the y value is 1. So what happens when you multiply by -2? You get -2. So it's down here. It goes like that. How about here? The y value used to be -1. -1 times -2 is 2. So it goes like that. And likewise over here, the y value was 1. It's now down at -2. It goes like that. Okay, so what I have in green is -2 secant x. Okay, you double all the values except reflect across the x-axis also. Okay, so if the red is above the x-axis, the green is below, and vice versa, as you can see here. Okay, so that's that one. Okay, then 25 was the last one of this type that I was going to show you. Y equals tangent pi x over 2. Even though they write it like this, think of it as pi over 2 x. That means like this. Okay, that does change the period, just like it did for sine and cosine. There was a b there. Okay. Now the period for the sine and cosine function was 2 pi, but the period of the tangent function is pi. So instead of 2 pi over b, for the period, it's just pi over b. So period is pi over b for tangent and cotangent. Period is pi over b for tangent and cotangent. So pi divided by pi over 2. If you divide by a fraction, you multiply by the reciprocal. So it's pi times 2 over pi, or 2. So the period is 2. How do I get a period of 2 and it goes through the origin? Then that means I just go 1 unit left and right. Okay, so instead of the original tangent function, which goes out to negative pi over 2 and pi over 2, a little bit awkward, it goes from -1 to 1, much better. And then everything else is the same. Goes through the origin, 1/4 of the way down at -1, 3/4 of the way, +1. So it goes like that. So same general shape, except this thing doesn't go from negative pi over 2 to pi over 2. It's scrunched in a little bit, only goes from -1 to 1. Okay, that's it. I'll just talk quickly, but I won't do it. Give you hints. 21, tangent x plus pi over 2. Okay. Take the original tangent function. Okay. And you move it pi over 2 to the left. 2 to the left. And how about this half secant x plus pi over 4? Right, so two things are going on. You've got the half. So let's see, where is my secant graph? Right. Secant, there's a coefficient of half. So rather than having a y value of 1, the y value is only going to be a half. And this one's going to be -1/2, right? So this one drops down. This one gets pushed up. Okay. That's just a half. And then on top of that, you move pi over 4 to the left. Okay, so make a note of that, if you would, for 23. Okay, pi over 4 to the left and multiply by 1/2. All right. Then find all values of t in the interval from 0 to 2 pi that satisfy the given equation. Okay, so I'll do some of these, and then believe it or not, I'm already done, folks. Okay, and if you want to ask me questions, you may, but I don't have to if you don't want to. Okay, so I'll do some of these. Okay. 29, tangent of t plus 1 equals 0. And we're going from 0 to 2 pi. 1 period, including 0, including 2 pi. Okay, tangent of t plus 1 equals 0. That means the tangent of t is -1. Okay, tangent is sine over cosine. Now, you might recall, when is a fraction equal to 1? Well, when the top and bottom are equal. When is a fraction equal to -1? Well, the top and bottom are opposites. Okay. So on a unit circle, the sine and cosine are opposites. So you know it's going to be a radical 2 over 2 thing, right? Because we know right here, 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 and here, both x and y are radical 2 over 2, except one's a plus and one's a minus. I want the tangent to be negative. The tangent is negative in quadrants 2 and 4, right? Or again, all students take calculus, right? So where is tangent negative? Quadrants 2 and 4. So what are these two angles? 3 pi over 4, 7 pi over 4. Okay, let's look at that one. 33 is only slightly different. Absolute value of tangent t is equal to 1. Absolute value. What does that mean? That means the tangent of t, if I kind of cover that up, sometimes I like to just cover things up like that. Okay, behind my pen, what numbers could it equal? So it's like saying absolute value of what equals 1, okay? If behind my pen was a 1, it's true. If it was a -1, it's true, right? So I say tangent of t is either equal to -1 or tangent of t is equal to 1, correct? If the stuff behind my pen came out to be 1, it's true, because the absolute value of 1 is 1. If the stuff behind my pen came out to be -1, it's still true, because the absolute value of -1 is 1. So that leads me to all 4 of these points that I just brought out. Because right here, the tangent of t is 1, -1, 1, -1. So I just have these multiples of pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Is that right? There we go. All right. So just do a couple more, and then we're just about done. So go back and do 31. Tangent of t squared equals 1/3. Okay, so let me show you that one. Tangent squared of t is the way I'm going to write it, equals 1/3. Okay, so do the square root. That gives you a plus or minus. Tangent of t is plus or minus 1 over radical 3. Okay, now you may not recognize that, but there's a nice little trick you can do. So I'll show you the trick. See, why do you do it? Because it works. Okay, so tangent is sine over cosine. I write sine t over cosine t. Then notice what I did. I divided the top and the bottom by 2. Okay, so how come? Because it works. Okay, so divide top and bottom by 2. And then you notice you just equate the top. Sine of t is plus or minus a half, while at the same time cosine of t is plus or minus radical 3 over 2. Okay? So I got this fraction equaling this fraction. I just set the top equal to the top, the bottom equal to the bottom. Okay. And then on my unit circle, I go like this. Okay, sine of t, that's y coordinate. Remember, cosine is for x, sine is for y. So I want the y coordinate to be either positive a half or negative a half. So I drew myself a unit circle. I go half a unit up, half unit down, go like that, and just figure out what these angles are. Okay, so again, half a unit up, draw a unit circle. It doesn't even have to be that accurate. Okay, if you're kind of close, it's good enough. Half a unit up, go like that, and like that. So what are these angles? So that looks like 30 degrees, right? And this is 30 degrees, and this is 30 degrees, and this is 30 degrees. And you can just base your calculations off that now. So 30 degrees is pi over 6. What's this angle? Well, if I go all the way here, it's pi. I take away pi over 6, that's 5 pi over 6. If I add pi over 6, it's 7 pi over 6. And then what's this one? If I go all the way around a circle, that's 2 pi. And then I back up pi over 6. So 2 pi minus pi over 6 comes out to be 11 pi over 6. So my 4 solutions are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, one in each quadrant. Okay. All right, then the last one I was going to do is 35, and then I'm pretty much done, folks. Okay, so it's a little bit harder though. So even though I'm on the last problem already, this might take quite a while. 2 sine 2t minus radical 2 tangent 2t equals 0. Okay, so that's a little bit tougher. And yeah, if any of you have questions, go ahead and start gathering up. So when I'm done in a few minutes, then you can ask them. That's up to you. Okay, first, I don't like this 2 pi. Okay, t is between 0 and 2 pi. So I temporarily call this angle theta. I would rather do it with theta, right? 2 sine theta minus radical 2 tangent of theta. Okay, so I'll make a substitution. Let theta be 2 pi, which means t is equal to theta over 2, or 1/2 theta. Okay. Now, what does that mean about the limits of theta? Okay, so when I'm working it out with theta, what are the limits? Okay, if I ignore all these 2's, ignore the red, you can temporarily ignore the red. So 0 is less than or equal to t less than or equal to 2 pi. That was given right here, right? 0 less than or equal to, can't cover this up very well. Here we go, sort of. 0 less than or equal to t less than or equal to 2 pi. Multiply all of these by 2, right? Multiply by 2, multiply by 2, multiply by 2. So 0 less than or equal to 2 theta, but what is 2t? But what is 2t? Theta. Less than or equal to 2 times 2 pi, 4 pi. Okay, so if t is between 0 and 2 pi, theta is between 0 and 4 pi. See, I need a relation in theta because they're related this way. So 4 pi is 2 revolutions. So as I'm solving it in theta, I have to go around the circle twice. Okay, so I got to keep that in mind. All right, so now this equation becomes 2 sine theta. The thing that I have circled is now theta. Minus radical 2 tangent. The thing I have circled again is theta. Equals 0. Okay, it's a little bit easier. Okay, unfortunately, I got 2 different trig functions. I got sine and tangent. So let's write tangent as sine over cosine, okay? So radical 2 sine theta over cosine theta. And I don't like the fractions, so I'll multiply both sides by cosine theta in red. Okay. So this is now 2 sine theta cosine theta minus, if we multiply cosine theta by this stuff, the cosine theta cancels out, right? So radical 2 sine theta, and 0 times anything is 0. Okay, I like that better. So at least I have no more fraction. All right, is there a common factor Yes, sine theta, right? So factor out sine theta, parentheses, 2 cosine theta minus radical 2 equals 0. Okay, you can see this is a pretty messy solution. All right, so that means sine of theta equals 0, or all this mess equals 0. This is of the form a times b equals 0. Little timeout here. It looks like a, b equals 0. If a times b equals 0, then either a is 0 or b is 0. So sine of theta equals 0, or 2 cosine theta minus radical 2 equals 0. Okay, solving here, if I add radical 2 and divide by 2, cosine of theta is radical 2 over 2. Okay, all right, so now I'm ready, but I want theta to be between 0 and 4 pi, so I have to go all the way around the circle twice. A little bit tricky. So sine of theta equals 0. Y coordinate is 0. So here's the y coordinate 0. So where does that happen? 0, pi, 2 pi, 3 pi, 4 pi. One more time. I made a substitution. I didn't want to work with 2t. But in the original problem, t was between 0 and 2 pi. If t is between 0 and 2 pi, what happens to theta? Since I made this relation that theta is equal to 2 pi, that's going to make theta go from 0 to 4 pi. Okay, and I forced it over here. So I have 1, 2, 3, 4, 5 solutions to this one. 0, pi, 2 pi, 3 pi, 4 pi. Then cosine theta equals radical 2 over 2. All right, I know that's going to be something involving 45 degrees. The reference angle is 45 degrees, or pi over 4. Okay, where is the cosine positive? If I do my all students take calculus stuff, quadrants 1 and 4. So it's here and here. Okay, so if I go all the way around twice, this is pi over 4. And go all the way into here, which is almost a full revolution, but not quite. So 7 pi over 4. Then I have to go around one more time. So this is 2 pi plus pi over 4, 9 pi over 4. And then keep going until I land back here again. That's 15 pi over 4. Okay, if I do 2 full revolutions, 4 pi, and I back up pi over 4, so 4 pi minus pi over 4 is 15 pi over 4. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 solutions for theta. But the original problem wasn't in theta, it was in t. Now, that's why back here I solve t is half theta. Okay. So I take all these solutions and divide them by 2. Just cut them in half. Okay. So here we are. 0, pi divided by 2, 2 pi divided by 2, 3 pi divided by 2, 4 pi divided by 2. Okay, so that's these 5. Then over here, you could say divided by 2. I'd rather say multiply by half, right? The multiplication gets easier. So half times pi over 4 is pi over 8. Half of that is 7 pi over 8. You basically just change all the denominators to 8. And then 9 pi over 8 and 15 pi over 8. Okay, so this was definitely a harder problem. Okay, but here are my 9 solutions in t to this original equation here. So 0, pi over 2, pi, 3 pi over 2, 2 pi, pi over 8, 7 pi over 8, 9 pi over 8, 15 pi over 8. Okay. All right, folks, I'm pretty much done. We still have 17 or so minutes. Okay, let me just tell you where we're headed. I'm not going to do any at 4.7, but we're doing trig identities. You might remember in trig that you did a lot of identities. You can put all these on your cheat sheet. Okay, I've already gone over some of them. Okay, so on page 239. And again, I don't like the way the author writes it. It should be sine squared x plus cosine squared x equals 1. this is correct. I usually put the 1 first. 1 plus tangent squared x equals secant squared x. 1 plus cotangent squared x equals cosecant squared x. So what the book has is correct. I would rather do it my way. Okay, so sine squared theta plus cosine squared theta equals 1. Yeah, the book uses t a lot, not theta. I like theta better. You probably had theta in trig. And 1 plus tangent squared theta equals secant squared theta. 1 plus cotangent squared theta equals cosecant squared theta. Okay, then you have all these other identities for a sum and a difference. Okay, I'm going to give it to you my way again. What the book has is technically correct, but I'd rather do it the way I got it. Sine of A plus or minus B. What's this plus or minus stuff? That means if you have the plus here, the plus is here on top. The minus gives you a minus. Otherwise, the formulas are the same. Please notice over here, though, that for the cosine, the SIGNs, the signs reverse, plus here, but a minus here, plus here. So how do I read this? Sine of A plus B, sine of a sum, is sine A cosine B plus cosine A sine B. And the minus means sine of A minus B equals sine A cosine B minus cosine A sine B. Okay, for the cosine, the plus gets a minus and the minus gets a plus. Okay, so cosine of A plus B is cosine A cosine B minus sine A sine B. And cosine of A minus B is cos A cos B plus sine A sine B. That's just the way it works out. Okay, your trig teacher may have shown you a proof of this. We won't go over the proof. We don't have time for it, but they are provable. You can prove all these. Okay, and then later you have double angle formulas. Okay, since this formula works all the time, it works if I put theta for both of them. So if I put theta plus theta, I would have sine theta, cosine theta, plus cosine theta, sine theta. So that means sine of 2 theta equals 2 sine theta cosine theta. So here's another formula. You can put that on your cheat sheet. And likewise for cosine of twice an angle, you can put theta plus theta here, put a theta here, and a theta here, and here, and here. So it goes cosine theta plus theta is cos theta minus sine theta, which leads to cosine of 2 theta. So cosine of 2 theta is cosine squared theta minus sine squared theta. Okay. And then I'll show you a couple more and then I'll stop. Okay. You can do a little bit of substitution. Okay. You could show that cosine of 2 theta is 2 cosine squared theta minus 1. You'd actually have to make a substitution because I know sine squared is equal to 1 minus cosine squared. If I erase this and put 1 minus cosine squared theta, you can make it look like this. Okay, and then a little bit of algebra. I won't go through it, but this is the result. Cosine squared theta equals 1 plus cosine 2 theta over 2. Sometimes this is called a half angle formula. Sometimes it's called a double angle formula, believe it or not. Well, one angle is twice the other, right? So if you go from here to here, you're doubling the angle. But if you go from here to here, that's half the angle. Okay. You will see this formula quite a bit in calculus, more often in Calc 2 than Calc 1, but it shows up quite a bit. So here's a formula for cosine squared of theta, 1 plus cosine 2 theta over 2. You can do the same thing with sine squared theta. Okay, I've got it here. I'm not going to go blow by blow over it, but you have this. You could do a little bit of substitution. You get sine squared theta equals 1 minus cosine 2 theta over 2. So here they are. Put them on your cheat sheet. But again, if we were meeting face to face, I'd make you memorize it, but we're not. So here we are. Okay, so cosine squared theta, sine squared theta. The formulas are almost identical, except this one's a plus, this one's a minus. So 1 plus cosine 2 theta over 2, 1 minus cosine 2 theta over 2. Okay. All right, so I'll put this away and stop. Okay, and about 9:47-ish. Okay, let me check the chat. I don't think I saw anything in the chat. Nothing in the chat. Okay, so you can ask me questions, either unmute yourselves or put it in the chat. I'll wait a few seconds, and if not, we're done today, folks. I'll get to your quizzes. But those of you who submitted a quiz on Friday or Saturday, I think I've already done it. And some of you just submitted it either Sunday or today. I'll get to it later. But yeah. So any questions about anything, please? Okay, I don't hear anything. So we're done, folks. So have a good day. See everybody tomorrow. Okay, bye. Bye.